So ladies and gentlemen, the time is just 4 o'clock in Tokyo time, and I'm really glad that you all came to this important webinar. My name is Kenzo Hiroki, professor of the GRIPS, National Graduate Institute for Policy Studies in Japan. Let me start with my own opening remarks. Your Excellency Ms. Lina Annab, Ambassador of Jordan in Japan. Professor Nijal Abjaba, Professor of the German Jordanian University. Distinguished faculty members, professionals, and students of GRIPS, Chinese Sichuan University, German Jordan University, U-Inspire, and other prominent institutes and organizations, and their colleagues. Good afternoon and good morning. Welcome to the joint online seminar on water and disasters, learning from history and culture. The seminar is co-organized by GRIPS and the Embassy of Japan in Tokyo. I sincerely thank Her Excellency Ambassador Ms. Lina Annab for her cooperation and dedication in organizing this meaningful event. Water has been closely associated with human beings since ancient civilization periods. It has been intertwined with the people in critical fields for their existence, such as health, food, energy, disasters, and the environment. It underpins social and economic development of regions and enhanced welfare and happiness of the inhabitants if managed properly. At the same time, water has been a major source of fear and concern as it may negatively impact people in the forms of drought and floods anytime, anywhere. Water has affected in many ways formulation of the culture and society. Learning the process of interaction between people and water will give us hints to build optimal relations between environment and humanity in the future. It will also help us explore better ways to adapt to climate and other global changes. In this connection, GRIPS have sponsored a series of global events to share experiences and lessons on water, disaster, and culture, including International Symposium on Water Culture in February this year, which was kindly attended by Their Majesties Emperor and Empress of Japan. Today, we are pleased to invite Professor Nijal Abjaba, Professor of the German Jordanian University and Head of the Center for the Study of Natural and Cultural Heritage. Professor Abjaba is a geologist working in the Department of Civil and Environmental Engineering at the German Jordanian University. He has almost 3 decades of experience in research and project development and management in the fields of geology, archaeometry, landscape studies, geochemistry, as well as surface and groundwater. In today's lecture, titled Flood Control and Water Management in Nabachi and Petra, Professor Abjaba will share with us long-standing history of Jordanian people in managing and living with flood and water. I am very much excited to learn from his distinguished lecture and exchange views on this important subject, together with over 100 participants today. This online seminar is a part of a doctoral course program on international policies on water and disasters at GRIPS, but globally open to viewers who are interested in this subject. I particularly welcome professionals and students of Sichuan University of China, U-Inspire and Alliance of Alliances on Water and Disaster Research, which are internationally active, and Professor Gretchen Kalonji, Dean of IDMR of Sichuan University. Questions and lively discussion by you all will make the event more meaningful and benefit stakeholders of your countries through your deepened knowledge and understanding. I look forward to this fruitful discussion today. Thank you very much. Now, I ask Ambassador Lina Annab to give her welcome remarks. Ms. Annab, you have the floor.
Thank you, Professor Hiroki, for this introduction. Good morning and good evening to all from rainy Tokyo. On behalf of all of us at the Embassy of Jordan in Japan, I'm delighted to welcome you to this webinar. Allow me to start by expressing my deep gratitude to our dear friends at the National Graduate Institute for Policy Studies, GRIPS. And in particular, I'd like to thank the president of GRIPS, Mr. Akihiko Tanaka, who has been extremely supportive in opening up potential channels of academic collaboration between Jordan and GRIPS. I would also like to thank our dear friend, Professor Kenzo Hiroki, whose role was pivotal in making this webinar happen. We were also impressed by how engaged and personally hands-on Professor Hiroki was throughout the preparation for this webinar. Thank you, Professor Hiroki. I'm also grateful to our speaker and presenter today, Professor Abu Jaber, who was immediately ready and forthcoming in accommodating our request to hold this webinar and to share with us some of his research findings. It is great that we have students joining us today, not only from Japan, but also from German Jordanian University, and from China's Sichuan University. And I also must extend my gratitude to the Dean of Sichuan University, Professor Gretchen Kalonji, for joining us today along with her students. We're deeply honored that you were able to be with us today. Thank you. Having students with us is a good opportunity to express to all of them how proud we feel of all the students who are with us today and students all over the world. The academic faculties, the administrators, all of them who due to COVID-19 must be facing major challenges and disruptions in their academic programs, and who continue to show resilience and strong will to give and to learn. Hybrid and online learning have become the most repeated words in academic settings, leading to anxiety driven by the uncertainty of the pandemic situation locally, regionally, and globally. To all of them, I send my best wishes and I encourage them to hang in there. We are all with you and we stand ready to help you in any which way possible. And as it is said in Japan, gambatte kudasai. Please, I think it's a tough time that you are going through, but I know that it will be soon over. And I think probably in terms of education, probably this is one of the most important lessons that we will all remember throughout our lives. Today's webinar was inspired by the symposium that was just mentioned by Dr. Hiroki. It's an international symposium that I attended at GRIPS in February in 2020, this year, on the subject of water and culture. And it's called For Learning from Water Heritage to Innovate Regional Development. During the symposium, it was wonderful to hear the president of ICOMOS, Professor Toshiyuki Kono, speak of Petra as a timeless model for the highly sophisticated and extensive water distribution systems that enabled it to flourish and expand. Although it might be coincidental, but today's webinar happens to fulfill some of the recommendations made after the symposium, and in particular in its call for, first, initiating a multi-stakeholder dialogues jointly by water professionals and heritage experts at local, national, and global levels to raise awareness, deepen mutual understanding, and inspire and strengthen the cultural values of water, and commit tangible actions on the significance of water-related heritages for sustainable future. Another recommendation that came out of that symposium was making use of power of ICT, artificial intelligence, and big data to identify, assess, and visualize water cultural heritage for everybody. Probably we did not foresee that we will need to use this ICT in the communication in talking about water, because it was just at the very beginning of COVID. We had no idea that we will be faced with what we are facing with today now. As far as Petra is concerned, Petra is probably one of the most famous archaeological sites in the world. It has been inhabited since prehistoric times, and the evidences are there. So this is what also makes it extremely interesting. Petra is on every traveler's bucket list. I have never met anybody who does not want to go to Petra. And even those who have been to Petra, they want to go back again. It is also repeatedly voted by independent surveys as one of the top places to visit in the world. In fact, just a few days ago, Petra was one of the top surveys done by the famous Lonely Planet travel guidebook voted Petra as the #1 place to visit in the world for 2020 and 2021. You might, 2020, we might write it off because of COVID, but we are hoping and looking forward to receiving guests in Jordan and in Petra in particular in 2021. So it's wonderful to see that Petra is up there. This you might have seen on the news because it was reported on international media. For us Jordanians, Petra evokes a myriad of affective feelings, from pride to fascination to love. Petra to us is the jewel in our archaeology and heritage crown. And believe me, we have many, many beautiful precious stones in this crown. But still, Petra always happens to be the one taking the top vote for everyone. The Nabatean civilization dates back from the 4th century before Common Era to the 1st century Common Era or after Christ, as we say. Petra was the capital of the Nabateans, as you know, which is situated in the southern part of Jordan. Petra is a UNESCO World Heritage Site. It was listed on the Heritage Site in 1985. It covers an area of about 260 square kilometers, or the equivalent of 26,000 hectares. It is one of the world's richest and largest archaeological sites set in a dominating red sandstone landscape. On so many fronts, Petra represents a masterpiece of human creative genius. Some of the manifestation of this ingenuity is the water management system, which allowed extensive settlement of an essentially arid area during the Nabatean, Roman, and Byzantine periods. And this is today what we will be learning more about. The remnants of the diversion dams, the tunnels, the water channels, the aqueducts, the reservoirs, and cisterns are an outstanding example of water engineering that the Nabateans had. In today's lens, Petra represents a badly needed model for the use of sustainable applied technology in creating dynamic and harmonized interaction between human populations and the surrounding environment. As we get ready to listen to Professor Abu Jaber, it is worth mentioning that his research, as complex as it is in using geology and archaeology to make sense of history and to learn from it, it also calls for a simple but powerful proposition. It calls for the idea of why not revive the ancient technologies of the Nabateans for use in today's agriculture and flood control in the area and in many other areas. I mean, this is something we always think about. If the Nabateans were able to do it thousands of years ago, why can't we do it today? Why don't we apply what was applied then today? Because we know it works. In the context of Jordan and in many parts of the world, as well, water harvesting as well as flood control measures are becoming of urgent need. Jordan's rank in annual precipitation is among the lowest 10 in the world. According to the Food and Agriculture Organization, the FAO, Jordan receives an annual of 111 millimeter in precipitation a year, while the annual global average is 1,155. Just to give you to put things in perspective, Japan's annual average is about 1,668. Jordan gets 111. So you can imagine how desperate we are in finding ways, in learning, in understanding how we can manage this resource in our daily lives. Climate and global changes are placing tremendous stress on resources, natural and otherwise. Access to clean and safe water remains a crucial and vital element for inclusive development. Even with the most basic requirement of washing hands due to the pandemic that we are experiencing, we are more than ever reminded of the importance of having safe access to clean and safe water. Water is vital to ensure peace and inclusive development. Again, we have great role models to learn from, whether it is the great Dr. Tetsu Nakamura, who tragically passed away last year, or the Nabateans, who existed more than 3,000 years ago, the importance of water can never be understated. In short, learning from our ancestors is a great way to mitigate the risks we face and to adapt in a responsible and sustainable way to the environmental and global changes we are facing. Once again, thank you very much. And Professor Abu Jaber, I can't wait to hear your presentation. Thank you.
Thank you very much, Ambassador, for your wonderful speech. That explains not only the the background, but also details of why Navati and Petra is important for the people of Jordan. This is very interesting, and now my interest in Navati and Petra is increasing more and more because of your speech. And also, thank you very much for encouraging words to the students who are having difficulty under COVID-19. And this seminar is one of the examples to show solidarity among the global people, Jordan, Japan, and China, and other countries. So we can unite to fight this COVID by listening to wonderful speech of Professor Nijar. Before asking Professor Nijar for his distinguished lecture, I have a few things to tell about in terms of the housekeeping announcement. First of all, after the lecture, there'll be a Q&A corner. We have the over 100 viewers, but you can ask questions by writing your question in the chat room of this Zoom. I will watch it out and ask a few of you to ask questions. If there are some similar questions, I'll ask one as a representative, but also I may ask questions on behalf of the those who made the questions. And for those who are listening from China, I have learned that some video difficulty exists in your university. So in that case, the Secretariat has already received a presentation slide from Professor Nijar. So that presentation slide will be distributed to you very soon, even while you are listening to the speech. So having said that, I cannot wait to learn more from Professor Nijar Jabbar. So as for his profile, distinguished profile, you have already received the invitation letter in which that brilliant career is already described. So I do not have to spend precious time for that. Now I'd like to ask Professor Nijar Abjabar for the lecture. You have the floor.
Yeah, thank you very much for all of these kind words and introduction and for the invitation. I'm definitely honored to be invited to give this presentation. And I give this presentation in my own name as well as in the name of all of my collaborators. One of the reasons the German Jordanian University was established was to start a different approach towards learning and towards research, because the German Jordanian University was established as an applied university with a hands-on approach towards research and learning, and with a view towards practical solutions rather than simply doing academic research. And with that in mind, it's important to think about what we know and what we learn in a more applied context, which is why the German Jordanian University actually established this Center for the Study of Natural and Cultural Heritage in 2011. And the idea of establishing this center was to create some sort of nexus for doing multidisciplinary research and providing applied solutions towards the different challenges that face both natural and cultural heritage in Jordan, which, as Her Excellency has just told us, is quite extensive in Jordan. We have a lot of jewels in our archaeological and natural heritage crown, and these jewels need to be taken care of. It's very easy actually to take them for granted when you're in Jordan because there's so many of them and it's all around us, and so we kind of dismiss them in many cases, and of course we shouldn't be doing that. But we're happy to have established this center, and we've received a lot of recognition and awards, including the Ikram Sharjah Award, which we've been shortlisted for this year. And I think we have a very good opportunity to win. So let's hope that happens. And you can always check us up on our website and see what we're up to. It's provided here. So we're talking about Petra, and we're talking specifically about the issue of flooding as well as water management. Most of the research I'm going to discuss here is concerning flooding. And it's important to think of flooding as both a blessing and as a curse, because for two reasons. One is because flooding provides water, and so it provides an opportunity to harvest water in this arid environment. But also the reason why we have Petra in the first place is because we have the action of water. That's why you have the physiography that's there, in addition to the issue of tectonics. So tectonics, climate and water interact with each other to produce the setting that was needed to have Petra in the first place. So looking at it from a tectonic point of view, we know that Jordan lies on this Dead Sea transform fault, which is an extension of the Red Sea transform fault, which is also extending into East Africa. So this plate tectonic boundary is one of the more famous ones around the world. And of course, Petra is lying right on the eastern boundary of the Dead Sea transform fault in southern Jordan. And of course, when you do have a transform fault, it manifests itself as a series of faults actually that create this very distinct physiography, which is very similar to what we have in Jordan. So if we look at this on Google Earth and we take the correct angle, we see that Jordan actually is basically a plateau that is cut at its eastern boundary by this Dead Sea Wadi Araba valley, which is of course part of the Dead Sea transform system. And you can see this gives us a lot of insight into what's happening in terms of water actually, because this highland up here and extends to the south is actually where we get most of our rainwater. But what happens is some of it runs off into these valleys and ends up either in the Dead Sea or in playas in Wadi Araba. But a lot of it also soaks up into the ground and comes out in terms of springs along this Rift Valley. So if we look at the older cities of Jordan, including Petra, we see that all of them tend to fall on this rift somewhere, because water falls onto these highlands, goes into the soil, recharges the aquifers, and comes out at springs. So we have all of these springs that are on this rift, and that's where we have Amman, and we have Salt, and we have Tafila, and we have Wadi Musa, which is where Petra is, because of this setting. So basically, these are agricultural lands up here, but the old urban centers of Amman, of Jordan, are along this rift. And of course, Petra lies over here. And if you look at the geological map, you might think, okay, what's this? Pretty colors. But what does it mean in terms of what we see on the ground? So what we have actually is the highlands. We have exposed this Upper Cretaceous limestone, and these are the upper parts of the rift margin where water, some of it soaks up into the ground here and some of it goes down into valleys, down into the lower parts. The lower parts includes this white sandstone, which is our division, what we call the DC sandstone. And this DC sandstone forms important outcrops both in northern and in southern part of Petra, but mostly in northern Petra, which is towards the rift. And if you go deeper, then you get the classic Ishrin red sandstone, which is where most of the ancient city of Petra was carved into. This is Cambrian continental quartz aeronite, and I view as a geologist. So we have the physiography, we have the geology. Of course, there's a lot of details to the geology because of the faulting and because of the different phases that happened before and during and after the faulting. But there's no need to go into that now. We have a lot of variation in terms of rainfall. This is from the Wadi Musa climatological station, which shows us this huge swing in amount of rainfall from year to year. So we have this erratic, let's say, pattern of rainfall that happens from year to year, as you can see. But you can also see that what we have is a lot of spatial variability in rainfall as well. So this is an example of one of the storms that happened in Jordan. And it shows, this is a radar picture, and most of the flooding that we see happens because of what we call these convective storms. And the nature of convective storms is that they're patchy in terms of their spatial distribution. And so how that manifests itself in reality is that if you're standing somewhere, it might be raining and you might move away a couple of kilometers and you don't have rain, or you have different amounts of rains, even within a small area. And this means, of course, that if you have one rainfall station, it may or may not be representative of how much rainfall you're getting. And so if you go back and look at this, you have to remember that this is one station, and you might have a different pattern if you have more stations distributed along the area. So this is something to keep in mind when you're thinking about the pattern of rainfall and how that's going to translate later into flooding events, which of course is dependent not only on the annual amount of rainfall, but on the intensity of rainfall, which is another limitation to the rainfall records we have, because the rainfall records that we have don't go back very far, and they don't give us the hourly, or we have at best daily records. And many of these rainfall events actually are very intense. They happen over short periods of time. And in order to properly understand the runoff, we need to properly understand the rain. And the rain is, again, you have the spatial distribution, you have the annual patchiness, and you have this issue, which is that you can get a lot of rainfall within a very short period of time. So if you get 10 millimeters of rain over 24 hours, it's very different than getting 10 millimeters of rain in 15 minutes, which is also something that can happen. And so understanding this variability is also key to understanding what's going on. Everybody knows this facade of the treasury at Petra. This is one of the iconic images in Jordan. And it's interesting to note that in 2000, 2001, this area was excavated for archaeology, and we find a second facade underneath the upper facade. And the implication of this, of course, is that this area was all buried because of flooding. And it's been estimated that this 5 meters of sediment that formed this platform in front of the treasury all was deposited in about at least 15 events within a period of 40 years. So within 40 years, you had all of this deposition that happened that covered up the lower part of the treasury facade. And so it just tells you about how much flooding and how much sediment you can get in this area. And it's important also to note that, okay, so you had 5 meters of sediment in 40 years, 2,000 years ago. And since the 2,000 years ago have passed, this platform seems to have been pretty much stable. So there was no sediments after that, which implies that there was some sort of intervention that stopped the flooding, or at least mitigated the flooding and mitigated the deposition of all of these sediments that used to come in here. Of course, Nabateans, as Her Excellency pointed out, are very well known for their ability to manage water. And this management system includes dams, cisterns, canals, pipes, spread all around Petra. Of course, there's a number of springs along the margin that I mentioned. The springs are not in Petra, they're in the upper reaches of Petra, in places like Wadi Musa and along that elevation. And so the water generally was brought into Petra through canals or pipes. And of course, as I noted, there's an extensive system of those, as I show you a map of it in a few minutes. And of course, the issue of water management is extensively studied, but what hasn't been studied very well in the past is the problem of flooding itself. And so just to keep a scope of what we're talking about in terms of amounts, we have a drainage area that's about 50 square kilometers. The long-term average of rainfall in the area is about 180 millimeters a year. And so if you just multiply 180 millimeters a year times 50 square kilometers, that gives you about 9 million cubic meters of water that are falling over this drainage basin. And individual floods of 4 to 5 million cubic meters, just one single event, have been documented. So again, this tells us more about this issue of variability that I keep mentioning. So you're talking about huge amounts of water that come in terms of both recharge of the aquifers and in terms of individual floods that go through the valleys and tributaries that are there that I'll mention in a few minutes as well. Of course, when you look at the dams that are there, like this one at Wadi Farasa, or this one that's in the upper catchment at Prague, these are dams that can contain at most about 2,000 cubic meters of water. So when you're talking about 2,000 and you have a bunch of cisterns and all of that and these little dams, you might add up to 20,000, and this is just an educated guess, about 20,000 cubic meters at most of storage capacity for all of these systems. So when you're talking about an individual flood that can be 4 or 5 million cubic meters, then you can understand that the scale of water management had to be mostly managed not through simply diverting water into these dams, which are obviously not big enough, but also thinking of ways to mitigate the issue of flooding that comes through every year or two. So this is an old map of all of the cisterns and dams that are in the area of Petra. And you, as I said, okay, these are important in terms of water management and providing what the inhabitants of the site needed at the time. So there was plenty of water for their needs. And then you had all of this extra water that was coming in terms of flooding. And if you kind of plot on this image from Google Earth again of the different flood management systems, you can see that they're distributed all along the eastern margin of the rift. Again, Petra is in this low area here. It's about, so just in terms of scale, in terms of elevation differences, you're talking about a difference of 6 kilometers along this length between the highlands and the center of Petra, about that. And then you have the elevation here is about 750 to 800 meters above sea level. And here it's about 1100 meters above sea level. So within 6 kilometers, you have about 400 meters difference in elevation. And so you can imagine how quickly the water will flow through those valleys simply because of the very high gradient that we have in terms of the valleys that are here. And so you notice that all of these water management systems are kind of towards the upper parts of the drainage system. So if you go to the lower part, I don't have any of those arrows, even though there are a few small terrace systems, especially at Turkmeniya and so forth. But generally speaking, the most significant interventions that were made to prevent the flooding were in the upper reaches. And here I'm going to focus on Wadi al-Hremiya a little bit, which is one of the small tributaries that it's small, but it's important. And the reason for its importance is that it floods directly into the plaza of the Treasury. So I showed a picture earlier of a flood at the Treasury, and the water from that flood actually was coming from this valley. So this is an important, even though it's a small tributary, as I said, it's important because a lot of the headaches that Dr. Suleiman and the other PDTRA officials have to deal with is the flooding that comes from this small tributary. So when we think about runoff from a quantitative point of view, we have to think about, again, the nature of the rainfall. Where does it fall? How much did it fall? How quickly did it fall? All of these issues we need to know. We need to know where we are within the drainage basin to think about what can be done in terms of management of these floods. We have to think about the slope. We have to think about the nature of the soil and the rock cover, whether it actually has an ability to soak up the water or doesn't soak up the water. So we have to think about the permeability. All of these issues, if we want to quantitatively understand what's happening at a specific drainage basin, we kind of need to think about all of these parameters. Of course, we have to ask where water goes. Some of it evaporates, some of it infiltrates, as I noted. And of course, what we're dealing with is what ends up as runoff. So we need to kind of differentiate the different segments of the hydrological cycle in order to be able to kind of, again, quantitatively think about management within these drainage basins. So this is a map derived from the digital elevation model of Petra. And the most important drainage system actually is the Wadi Musa drainage system, which kind of flows down, goes into the Siq and comes out at Wadi Siq. And so many of the more dramatic videos we see about flooding actually comes from the integration of water coming from different sources in this upper part of the area of Wadi Musa, and then goes down into this lower area into the Siq and then out. We have one of these side wadis at Hremiya. Wadi al-Hremiya is relatively small if you add up all of these sub-basin areas. So this is about half square kilometers, 0.07 square kilometers, 0.11. So all of it adds up to about maybe a couple of square kilometers, which is of focus of a lot of what we're doing now. So if you want to take one of these small sub-basins and consider what happens in it and how flooding occurs, this is again the Hremiya area magnified. This is where we are in Jordan, of course. And this is a map of the water flow. This is the Wadi Musa area. What happened in the Wadi Musa flooding is actually it comes through the Siq, which doesn't show on this picture. What the Nabateans did, one of their flood interventions was they cut off the water that goes into the Siq by building a dam and then constructing a tunnel that goes around this mountain that's here, that's called Jabal Khubta, and then it comes out around here. So that's one of the flood interventions. So not all of what they did was terracing and flood management of the headwaters, especially for Wadi Musa, because the scale of the problem was too big to be dealt with simply by terracing in the upper regions, even though they did some of that too. And then you have other tributaries to the south, which form less of a problem, let's say, for the management of the site. So this is basically the biggest headache for the site is this. The Nabateans did build an extensive terrace system to collect the water. And of course, just thinking of it in a rational way, you couldn't, again, store all of that water in the available cisterns and dams that existed because simply they weren't big enough. So the only way to control this or to mitigate it, let's say, was to encourage the water to be infiltrated into the soils. So basically, the most important approach to flood management was to encourage soil infiltration rather than storage in open reservoirs. When you consider the amount of soil that you have and rocks and aquifers, it becomes clear quantitatively that you have much more capacity to store water and soil than you do to store it within dams or in cisterns. So, and people tend not to think about soil water as being stored water, but in fact, it is stored water. Any water that's in the soil that the plants can use, that you can use for agriculture or for forestry or for anything else, is useful water. So the idea that, okay, you lost the water in the soil is not particularly accurate. Encouraging water to infiltrate into the soil does provide agricultural opportunities as well as the ability to mitigate the flooding problem, as I keep saying. So the increasing the infiltration was generally done through encouraging infiltration within these terrace systems. So what are terrace systems? Basically, terrace systems are artificially constructed walls. And you might wonder about the soil, whether this soil is fill actually, or is it pre-existing soil that people have built these walls on? And of course, depending on where you're looking, you have both cases. Some cases you have people who have built the terraces to just stabilize the slope and make a flat surface, and that will encourage infiltration and discourage runoff. We have these stone wedges which stabilize the soil and prevent the swelling of clays affecting the stability of the wall. So we have a lot of tricks that have been done to increase the longevity of these structures. So you have different shapes and forms actually of these terraces. You don't have one type of terrace. You have a number of terraces that perform multiple functions. And so these include collection of soil and silt, again, slowing down the flow of water and creating these level surfaces that can be actually plowed and planted. So there are multiple functions. And if you look actually at the functions of these dams, you can see that they include water collection and soil protection and enhancement. So there's different typologies that perform different types of functions. And if you look again at our small catchment at Wadi Hremiya, you see that this is how these terraces and gabions and check dams are distributed. And if you look at them, you'll see that they actually are not all the same. So if you look at the upper parts of the catchment, you find these gabions. And these gabions, as you see, are different thicknesses from top to bottom. And they're designed, of course, to hold back the sediment to prevent the collapse. Because again, one of the problems of flooding isn't just water, it's the debris. And so the issue of soil protection is not only an issue of agriculture, but it's also an issue of protection of the site. Because if you have all those canals and you have all those facades and all of these things in the bottom, you don't want them to be buried in sediments. So the issue of sediment control is just as important, if not more important, than the actually control of water, which, okay, water is a menace during the flood, but the deposition of sediments is a much more long-term problem if that becomes an issue. So you have gabions in the upper parts of the catchment. In the middle part of the catchment, you have this type of design called Valerani types of terrace structures. And the idea here is not simply to hold the sediment, but actually to channel the water in a sideway manner, and that will lengthen the flow of the water. So instead of the water just going up and down, it's kind of being sloshed from side to side. And the idea, of course, is to lengthen the water path to increase the soil infiltration, and of course to decrease the gradient, because of course the water is going sideways with this design. It's not only going from top to bottom. So we have this type of system in the middle part of the slope. And then if you go to the bottom part of the slope, you see these very distinct check dams. And these were the last line of defense for flooding. The more important ones actually are the ones that are in the upper parts of the catchment. But we do have a series of these dams at the bottom too. We have one here, we have one here, we have one here, if you notice. And these, of course, are designed to, again, more slow the flow of water than to actually collect the water. So it's kind of a more tempering effect rather than a collection of water. So what did we do? Well, in order to understand this whole system, so we can see it, we can measure it in terms of what's there, and I'll go through that in a few minutes. But what we need to do is understand the system from a hydrological point of view, because it's all well and good to say, okay, we have all of these systems, and this slows down the water, and this increases infiltration, and all of this is very qualitative. And what we wanted to do is to be more quantitative in our approach. So we want to know exactly what is the terrain? What is the slope? We need to have, how do these terraces fall on the slope? Where are they? How do they change from location to location? We need to quantify the runoff infiltration relationship. How much is runoff and how much is infiltration under different types of conditions, under different types of soil? We need to quantify that. We also need to understand these. Of course, I gave you some of the functions and how they're designed, but that was also part of what we've done as a team here. Then what we want to do is to create these computer models that will simulate what happens. So, of course, anybody who knows anything about computers knows the term GIGO, garbage in, garbage out. And so if you want to do a computer model, you want good data. And you want good data, you want good understanding of terrain, you want good understanding of the rainfall, you need good understanding of the infiltration, you need a good understanding of the runoff, because okay, you say flooding and 4 or 5 million cubic meters. These are, of course, on Wadi Musa when we say 4 or 5 million cubic meters. But what about Wadi Hiremiya, these smaller tributaries? How much water flows in them? How quickly does it flow? So we need hydrographs. We need to monitor the runoff as well. So none of this data was actually available before we started. And so in order to have a very good understanding of what's happening from a hydrological perspective, we needed to go in and have a better understanding of all of these different types of components of the model. Before we could actually do any computer modeling, we needed to have real data, because prior to what we've done, we didn't have the quality of data that we needed to have a very good understanding. So we start with the idea of understanding the site. Of course, we have a digital elevation model. Digital elevation models are much coarser in terms of their resolution than what we needed. So we had to do on-the-ground surveying using drones and real-time kinematic surveying. And this allow a better modeling of how water will flow through this basin. So we did this scanning of the site. This is our colleague, Dr. Abdullah Rawabda, with his drone. So we did a very good scanning of the site using this, also using this real-time kinematic. And this allowed us actually to create a very high resolution map of the drainage basin, which I'll show you some of it here. So these triangles are actually data points, and this is all after we did a 3D scanning of the site. We were able to actually, these aren't photographs, these are 3D scanning of the area. And so you can go up and down the drainage basin, and you can see individual plants, individual rocks. Of course, more importantly than any of these specific objects that you can see, you can actually measure distances. So we have a very, very high quality database for where the terraces are, as you can see here, plus their heights, plus their thicknesses, plus the slopes, plus where the soil is, plus where the rocks are. All of these things are now available in not just as photographs, but we can actually give exact coordinates and elevations for every single point within this drainage basin. So we're going up the drainage basin now from the lower part to the higher part. So we have this very high quality data. And yeah, so you can imagine thinking about this in terms of modeling. How does the water flow over these rocks and so forth? So yeah, we have all of this information now. I think we're showing off a little bit too much here. So let me go to the next slide. So this allowed us to create very high, again, resolution maps of both the terrain and the distribution of these terraces, as well as the different types of terraces. So we know the typologies, we know the locations, we know the terrain, we know pretty much everything there is to know now. We needed to understand how do these different surfaces respond to different types of rainfall events. So we actually took a rainfall simulator to the site and did a number of experiments. And experiments were not just at Wadi al-Ihramiya, but we actually did in different locations around Petra, in the area of north of Sayhoun here, as well as Bega over here, plus Ihramiya over here. So we have different locations where we can say we know how the rain runoff characteristics change, both in terms of intensity and quality. So we were trailing these torrents, trying to find out where they are using this device called the rainfall simulator. And just for anybody who's curious about what this rainfall simulator does, it actually sprays water. It's a sprinkler. And basically you sprinkle the water on the ground, and then you collect the water that runs off, and you can, what happens, of course, is when you first start to sprinkle, the water is all absorbed, but at some point you start to generate runoff. And then when you start to generate runoff, you can see how much runoff you have compared to how much water you're putting in. So you know how much water you're putting through the sprinkler. You're measuring the infiltration of the soil at the initial stage, and you're measuring the amount of runoff after you start to generate runoff, and then you reach some sort of equilibrium. So you never reach a point actually where the total amount of water that's running off is exactly the same as the water you're putting in. You're always having infiltration. So this system actually gives us a very good insight into how much rain runoff relationships have. So we took this to Petra, and we again, I explained how this works. And so this is us doing this work near Wadi al-Ihramiya and the upper slopes. This is the site we investigated in north of Sayhoun. And again, of course, it's related a lot to the texture of the soil. So we have different types of soils. It turns out that if you look at the different parts of the escarpment, you have, and whether it's terraced or not, you see that the terracing actually changes the components. So you have more silt and clay in terraced areas than in unterraced areas. And so this, of course, when you have silt and sand, that encourages infiltration. And so when you have a terraced surface, what happens is basically you start putting in, then you start to generate runoff after, so this is in liters per meter, you start putting in 2 liters per minute. And so initially you don't have any runoff. After about 14 minutes, you start reaching an equilibrium of 1.4 liters per minute, which means, of course, that you're still infiltrating about 0.6 liters. So this is useful information to understand how terraces work. If you look at unterraced surfaces, what you have is, of course, different. Terracing actually encourages infiltration. Then we need to understand rain, and we need to understand runoff. And so to understand the rain, we set up a number of rainfall collection devices all along the drainage basin. So we actually have a number of stations that are collecting information on rainfall so we can have a better understanding of how sporadic the distribution of rainfall is in a spatial level. And of course, we need to understand runoff, because if we don't understand runoff, then none of what we measured beforehand can be calibrated or understood very well. So we installed a number of these rainfall gauging devices all around the area. These are tipping buckets. These are commercially available, and we bought them and we installed them. We couldn't find commercially available runoff devices, so we had to build our own. One of the problems with runoff in Jordan, generally speaking, is the fact that you need to monitor runoff at different places along drainage basins to understand exactly what's happening. We don't have many of those in Jordan. And when we do have them, they're on the main tributaries of the wadis. And the reason, of course, is because they're expensive, first of all, and secondly, because they're subject to vandalism. And so we thought we're going to devise these runoff devices that will measure exactly how much runoff we're getting. Actually, this measures the level of water, and electronics here are processing this data. And then we have antennas, and the antennas actually are sending the data right to our labs at the German Jordanian University. So we actually are collecting real-time data of runoff whenever runoff events occur. One of the advantages of this system is that it's kind of cheap, relatively speaking. And so when they get vandalized, which once in a while this happens, recently these exact ones were vandalized, but it's okay because we can rebuild them and reinstall them. And it doesn't cost very much. The only thing we lose essentially is the data during the time that they're not deployed. So we have runoff. So we have all the elements we need in terms of the hydrological cycle to actually put together models for the rainfall. So we use Dr. Qasim Abdul-Al, who's actually doing the hydrological modeling for us, and he's the one who oversaw the development of these runoff devices as well. We have now enough information to put together to create real models using this HMS software, which actually is useful for understanding amount of runoff, the length of the runoff events in terms of time, and how quickly the water passes through. And in addition to that, if we set up or rebuild these terraces, what will happen? Because the fundamental question we always want to get back to is how will this information be useful? And so what we're doing is actually saying, okay, now we have all of this data. What will happen if we rebuild the terrace system? Well, quantitatively, how will it mitigate the flooding events at a real level? So in order to do that, we had to bring a whole bunch of stakeholders on board to think about rebuilding this terrace system. And so we got together on March 19th last year, and we got all the stakeholders, including the funding agency, the UNESCO, the ICOMOS, local NGOs like the Petra National Trust, ICOMOS, the governing authorities for the site, which include the PDTRA, plus the Department of Antiquities of Jordan, plus people from the local community. We all got together and kind of thought about the different options we have in terms of rebuilding these terraces to see exactly how well they would work under monitoring, modern monitoring conditions, let's say. We thought, okay, we have this need to rehabilitate the site. So this is us kind of setting things up. We have a little crane there. And we said, okay, what are the choices that we have? We have different options in terms of design. One of the issues we have to deal with when we're dealing with Petra is, as was mentioned previously, Petra is a World Heritage Site, which means that we can't do exactly whatever we want. We can't get a concrete mixer and start building dams there. That's not an acceptable intervention. And so the building or rebuilding or rehabilitation of these terraces actually has a number of ethical and let's say aesthetic implications that need to be considered. So you can rebuild these terraces in different types of ways with different types of materials. One of the ethical issues is that generally speaking, modern interventions have to look like modern interventions. Because if you build something that looks old, it's kind of deceiving for anybody who's looking at the site. So we said, okay, Yani, how can we rebuild these terraces in a way that's acceptable from the perspective of UNESCO, which wants to maintain the integrity of Petra in terms of a World Heritage Site, which means the nature of the interventions that we do there have to be acceptable from the perspective of the different conventions that have been adopted to manage World Heritage Sites. So we had that. So we said, okay, we can do this, we can do this, we can do this. We decided what are the different options and what we would like to do. And then based on that, we started working on the rehabilitation of the site. And this is our architect, Safa Juda. And these are some of the workmen working on the lower check dams in the area. We started to do that. So here's some of the local community. One of the aspects that are important to note here is that we involve the local community in the rebuilding. So all of these are local workers who are not only benefiting from the fact that they're getting a job, but they're also learning how to do this type of work in an acceptable way. So it's an employment opportunity, but it's also a training opportunity. So involving the local community actually is quite important to everybody involved, because we want to be able to finish this project and say we left the skills and the knowledge needed to actually be able to continue this work and also to rehabilitate these systems without too much outside supervision. So we have that. Yeah, we rebuilt these with various levels of success, let me say. And anybody who wants to follow up what we're doing in Petra can follow our ResearchGate project page for geoarchaeology of Petra. We have a whole bunch of things we're doing down there. So this is one of them, and yeah, you're all welcome to join, and if you're interested. And we're going to be updating this for a long time to come, I think. So thank you very much.
Thank you very, very much, Professor Nijal, for this extremely interesting lecture. I'm quite thrilled to learn the techniques and knowledges of the ancient Jordanian people who are really genius. I want to start the question and answer section, but before that, we have an important guest here. Here from Jordan, we have a participation from Mr. Sulaiman Farajat. He is the Chief Commissioner of the Petra Development and Tourism Region Authority. He is a very high person. So if Mr. Farajat, if you can listen and speak.
Yes.
Wonderful.
Thank you, Professor, and thank you, Ms. Ambassador, for this opportunity again. And thank you for Dr. Nizar for the presentation. Unfortunately, I couldn't join the presentation from the beginning, but I am very much familiar with this project and its outcome. In general, I would like to highlight that the region of Petra as a World Heritage Site has a very fragile situation, especially in terms of flash floods. And there have been over decades so many studies. However, in the last 2 years, there have been more specific studies. One of them actually was coordinated with the UNESCO office in Amman, which is a comprehensive plan to look at water flash floods in the region as a whole, beyond Petra as an archaeological park. And we are now in the phase of looking for partners to develop some of the strategies suggested in this document. As per the project that Dr. Nizar discussed, as the BDTRA, we have worked closely with the Department with Jordanian universities in order to work in a micro level in such projects. This project has been now in Petra for almost 3 years. And the good thing, we are revising some of the techniques used, and we use it also as an opportunity to employ local staff from the side of the BDTRA. We very much appreciate this involvement, and we very much support, and also our partners from Japan, from all over, to be involved in this project in the future. Besides the outcome of this project that we are also expecting, the process itself for us, it's an experience. It's something we learn from. It's also a learning process for our staff at the BDTRA. And you know that Petra is not only important in a local or national level, it's a World Heritage Site. It's important for all humanity, and we are open for any intervention. And in this occasion, I also would like to thank the efforts Her Excellency Ambassador Annab is doing to position Petra as not only as a tourism destination for the Japanese people, but also in terms of supporting research, not only in the field of heritage and tourism, but also other fields. And we very much appreciate that. And we will continue working with Dr. Nizar and other organizations in the near future in order to protect Petra for the future generation. And I want again to thank you all parties for facilitating and making this happen. And you are welcome to visit us in Petra at any time, hopefully soon. Thank you.
Thank you very much, Mr. Farajat. This is the great example of the collaboration between academia and the government in trying to preserve the heritage that is an asset not only for Jordan but also for the world.
Indeed.
And I'm really glad that the Dutch, Japanese, and other partners are working together to raise profile of the water and culture in the organization of e-commerce. Probably we can convince them to include Jordanian initiatives to highlight the importance of water-related culture in the entire e-commerce organization.
We would be happy. You are welcome. Thank you for this.
Thank you very much for wonderful intervention at the beginning. Now I will enter into the question and answer and the discussion section. Before asking everybody to ask questions, which might be hundreds, I would like to ask the Professor Gretchen Kalonji, the Dean of the IDMR of the Sichuan University. Gretchen, you are still in quarantine from the trip to Tokyo to Chengdu. Thank you for joining us.
Day 3 of 28. But anyway, first of all, let me just say how tremendously exciting your talk was, Professor Abu Jaber. I mean, it was a wonderful honor for our faculty and students at IDMR to benefit from your experience. And I also would like to thank Professor Anab for her very kind remarks. But basically, I have more of a comment than a question. What's really, really striking and exciting to me is the degree of commonality that we have between your region and your university and your World Heritage Site, and our region and our university and our World Heritage Site.
Okay, we can talk more.
Yeah, as many of you know, Dujiangyan is one of the hallmarks of flood control and irrigation system, and created incidentally at the same time period as the Nabatean Jordan, 2,300 years ago, still in action. So the other thing that we have in common in terms of the modalities of research and education between your center and your university and our institute and our university is a commitment to multidisciplinary team-based research, a commitment to international partnership, and a commitment to getting the research into action, doing things that really have a result. So very briefly, I would love to explore the possibility of some concrete projects that we could develop together between your center and our institute, focusing on very broadly on the issues of flood control and water management and the relationship with both natural and cultural heritage, because we have so much in common in those areas. So if you would be interested, I would love to follow up. That would be great. A very brief question though. The other thing the regions have in common is they're highly seismically active. Yeah. So can you give us a little bit of an insight about how the seismic history played into the Petra in general, or any other aspects of the hydrological?
Tectonism is a very important issue. That's definite. Basically, the whole region actually is now being eroded away. Especially the more recent Pleistocene sediments are being eroded away because of tectonic movements in the last 15 or 10,000 years. So, and you understand, geologically speaking, you're talking about a very short period of time. So, so the area actually is highly dynamic because of this tectonic nature of it, and that's part of the challenge. Is you're saying, okay, we have this area, it's beautiful, it's also in the middle of a trading route, and it's also arid, and it's also highly dynamic in terms of sediment and water movement through it. And so it's a wonder why anybody bothered with it, except for the fact that it's a very important trading route. And so it seems that everything was done with that in mind, in terms of holding back the sediment, holding back the water, because we have evidence not just in Wadi al-Haramiyya, but in all kinds of other places around Petra, where people were saying, okay, we have this agricultural land, we have this setup in terms of roads, in terms of everything, and it's being washed away. So because of, again, this changing base level that we have. And so, tectonism and seismicity. Seismicity, of course, is a problem for individual structures for a short period of time, but the long-term impact of tectonism was more of a thing that they were dealing with throughout this process of managing the site.
Okay, thank you. Well, let's follow up together.
Okay, yeah, I look forward to an email from you.
Sure.
Okay, great.
Very good initiative. And now a question from the audience. If you have any questions, ask questions through Zoom group chat, Well, just you just open your microphone and ask questions, whatever you have. I see Mr. Bowen. Bowen, are you there? You can, yes. You can ask your students to ask questions, and on behalf of the students, you can ask.
Okay, let me ask the student first because I don't know if I have questions. 所以大家有没有什么问题，想要问的，就是对这个课程。
Please ask question clearly.
I think
I
think
have a question. Hello.
Oh yes, this is our professor Liu Zhipan.
Okay, go ahead.
Thank you for the very wonderful lecture. I'm IDMA. I'm an associate professor from IDMA, and my question is that the max from the material we know that the terrace, the device is increasing the seepage flow and reducing outflow. Sounds like the proposed response city. If this device can be applied to the disaster prevention and mitigation in mountain basins, maybe it is of great application value. At the same time, I want to ask. I don't know how. I just want to ask the city's flood control standard in the research area, and regarding the application of a terrace in mountain areas, will the content of a sediment will block the device? And the standard, is there any standard for the content of a sediment for a device? The terrace in the area is similar to a step named the step deep pour used in the mud flow prevention device in China. The mountain river of southwest China, but the deep pour is just tracked stacked with stones with different sizes in the river ditch or maybe in the river. If the device for a terrace proposed is used for disaster prevention, maybe in China, how? I just want to know, is there any problem for cost? The cost, for economic cost problem is there? Because the use is very much area need such kind of things. Thank you.
So I think you're asking about. I'm not sure I understood your question because the quality of the sound wasn't consistent. But I think you're asking about the devices that we were using to measure the runoff. I think the runoff measurement devices you're asking me about, or the terraces themselves. I'm not sure, but the issue of calibration of the devices, I think that's the question. Yeah, I mean the calibration is basically based on the size and the shape and the slope of the channel that we were using, and so obviously there's standard techniques for calibration. And of course, the movement of sediments through it will change that calibration. And so the idea is that yes, it's not perfect, but it's much better than not having any data at all. So that's how I see it.
Okay, thank you. Thank you very much.
So I have a number of chats here. So should I just read them or?
Yeah. If they can make a short comment, Mr. Majadul Rahman,
Uh-huh.
can you say your question?
Yeah, he's asking about the stability of the terraces and the risk of it.
Yeah.
Our colleague, Katrina, who is our expert on terraces.
Okay.
Saying,
So she already
yeah,
answered the question.
sorry.
Okay. Other question like Mr. Tedra.
Hello, yes, Professor. Thank you very much for the presentation. Actually, my question is more of related to policy issue. Just wondering, like, how can we integrate this cultural heritage protection and water resource and basin development interests in a large scale where there is many countries in a transboundary, like the Nile. So how can we integrate this issue in such cases? Because there is a large conflict in these countries because of lack of agreement. So that's my question. Thank you.
Yeah, I'd say that the scale issue is important here. Obviously, we're talking about a very small drainage basin with a small amount of water, and it's not obvious that this system can be scaled up to something like a major river, simply because the amount of water that you need to control is much too large for anything that will make a difference in terms of starting a war between countries or anything like that. Maybe herders will fight over it, but not countries. But generally speaking, it is I would see it more as an opportunity for collaboration, because obviously flooding and optimal use of water is of everybody's benefit. The way these transboundary waters are viewed now is more as a zero-sum game. So you're looking at people saying, okay, we have a specific amount of water. What's your share and what's my share? And we have a discussion or a fight over that. And one of the underlying messages here is that not all of this water actually is being accounted for, because we have a lot of water that's kind of going, it's being wasted during flooding events and so forth. So actually, both at a national level and perhaps at a larger level, if it can be scaled up, you could be talking about actually increasing the amounts of water that are available, which should lower tensions, I would hope.
Thank you. Any other question? Mr. Rahman, do you have any additional question? If not, I have one question. May I?
Okay, good.
Yeah, this is great. This is real integrated water resources management 2000 years ago. And I was very much impressed and surprised how much detailed, they have designed this system. So who did that? Is that the leader who did that? Is that the community? Is that a group of the engineers or the small leaders or the priests or religious people? Who did that? And then is there any study on that?
Well, I'll let my colleague Katrina answer that question.
Thank you so much for the question. Actually, it is a very complicated issue when you talk about building of terraces. When we in our study covered the basin of Petra, and we have found out that some of the designs, they are used in the same way in the same area of the catchment area, despite the variation in material or in methods, which in my opinion, it goes into that there had been a group of people who are being trained, who knew how to build terraces and how to intervene with these terraces in various locations. Now, when you're talking about small landowners, when they wanted to terrace their land for agriculture, we have evidence that it was actually done by the family, using, for example, the stones, and there had been a division of work. So you will have the owner, where he could do in help with the different workers to build up the terraces walls. And you'll have a minor, group of the community, for example, women or small children, who could provide the small stones. But still, you needed to have at least one person or two who are masons, who will know how to cut the stones, because in building a terrace, the design of the wall, you needed to have specific wall, stones. You need to have also wedge stones that will be wedged into the wall to make, sure of its stability and its form. So in these parts, I think it was both from the government and also from the local community. Some inscriptions that we found in various locations actually mention of building a terrace or a dam with a set of terraces or walls, and these were dedicated to Nabatean gods. For example, we have, in area in Wadi Araba, we have in some areas in Beida, inscriptions that dedicate this structure to Arita, done in the time of the Aritas, to Dushara. And this is, to invoke the protection of the god, and also as a part of, giving and forgiving and, working on it. In addition, there was an aspect of maintenance where these terraces need to be maintained. And this was probably done, if it's owned by the landowner, he will do it in each, in the summer before the winter time. And if it was, for example, a part of a road, we have, indirect indications that it could have been the army who was actually collecting taxes for the road. They also maintained part of the terraces that protected the roads. So it's a combined system between local communities and the government, forces that work together in order to make the whole system work.
Thank you very much. It is very interesting. So I have actually a memo with a dozen questions, but I cannot ask it, maybe later, since the time has come. But it was extremely interesting 1 hour and a half. And then although we do not want to conclude, it is my duty to enter into the closing session. So before my closing words, I'd like, Lina-san, are you still here? Ambassador?
Yes, I'm here.
Yes, may I ask you, concluding remarks?
Thank you, Professor Hiroki. This has been extremely enlightening and inspiring as well. Thank you, Professor Abu Jaber. It's wonderful to see how you have put again, the research findings to be applied into practical and into important solutions for today's problems. Flash flooding is a problem that we continuously hear about in Petra, and it's incredible to see that the Nabateans were able to control it, and even not only control it, also make use of the water, not having it wasted, in reserving it and in making use of it for whether it is drinking water or even agriculture. So this to me really to see that there is something happening and there is some collaboration in terms of rebuilding some of the terraces is wonderful. And actually, I had a question, but I will ask it, but I'm not going to wait for an answer because I know the time is up. But it would be extremely interesting to learn if there has been a simulation about rebuilding all of the terraces that we know of and what the impact of that means, whether it is on agriculture or in saving water. But again, I'm not waiting for an answer, but this is something that came to mind as you were talking. Thank you, Professor Abu Jaber. Thank you, Professor Hiroki. Thank you, Dean Gretchen, Professor Hamarne. It's so wonderful to see you and to hear you. Thank you to Dr. Farajat, the Chief Commissioner of Petra PDTRA. It's so great to see everybody, and I hope we can do this again. I hope we can do it in Petra in person, but if not, I hope we can have similar webinars in the future. GRIPS, I can't thank enough. We're so proud of this association, and we really look forward to doing more things with you in this field and in other fields as well. Thank you so much. Domo arigatou gozaimashita, and you have been great. Thanks a lot.
Thank you very much. Thank you very much, Ambassador Lina Anna. My real last words. And then I think everybody agrees that this webinar was very much of the success, thanks to wonderful presentation by Professor Nija Abu-Jaber, but also with the cooperation by the Embassy of Jordan here in Tokyo. And I'm also grateful to all the participants, particularly those from China, and Professor Gretchen Kalonji, and the international students and faculty members of GRIPS and other university and institutions. This is the just a conclusion of 1.5 hours, but at the same time, this is the beginning of the real cooperation among all the international people. The Professor Najjar's presentation shed a scientific light on the importance and significance of investigating the relations between water and culture. And we can learn from these examples to benefit our next generations in terms of water management, in terms of culture preservation, and in terms of the heritage enhancement. So, we have, shortly discussed about future collaboration. And I'm sure that we are all motivated to continue it with a determination to continue our collaboration through webinars, through the actual works. I'd like to conclude session by thanking all for participating in this session until the last moment.
Professor,
Thank you very much.
Can I say one thing, please?
Yes, please.
On one of the screens, I noticed that the entire Department of Antiquities in Jordan, including the director of the Department of Antiquities, are also listening to us. So I just wanted to say hello to them and to thank them very much for being present, and also to share with everyone that the entire Department of Antiquities in Jordan is watching. And if they say something, it says how important this field for us and how important this subject is for us on all levels, whether it's academic or even government side. So I just wanted to say hello to them and to thank them for being with us today.
Thank you very much from me to all the Jordanian stakeholders and officials and people who spent their precious time to attend this important symposium. Thank you very much. The session is concluded. See you soon.
Thank you very much.